when we talk about infrastructure considerations, there's several things, right? There's your traditional coax, category cable, fiber, multi-mode, single mode, and wireless solutions. And again, it's not a one-size-fits-all. So we're going to talk about the different options for either yourself as an end customer or if you're an installer, considerations for your customers. Different types of CAT cable for Ethernet cable. I came up and decided I'm going to read every single word off this slide. So I'm not kidding. Basically, there's two key things here to look at. We're looking at megabits per second and megahertz. And it essentially comes down to the amount of data that we can push through and how quickly we can push it through. So when we look at different category cables, you'll see that there are limitations in terms of bandwidth. And that's, again, from a consideration standpoint, do we use fiber? What type of fiber? Do we use Cat 5? Do we use Cat 7? These are things that you'll want to take into consideration. So again, here, just kind of a real quick snapshot of the different types of category cables. So 5 down to 7 with the different acronyms, with the big things. If you look at the standard bandwidth and the max data rate, that's really kind of the one thing to look at in terms of what is in your environment, how much data are we pushing, are there limitations, are there restrictions, what's going to be best suited for us. And then lastly, I think most of you know, anyone who's dealt with video security and PoE, 100 meters, right? In terms of that 333 feet roughly of limitations for PoE. So that segues into the conversation in terms of if we need to go beyond that, what options do we have? So with that being said, I'm gonna kick this over to Steve and ask Steve a question in terms of fiber optic cables. So Steve, can you talk a little bit about when we look at fiber, single mode versus multi-mode, the difference and maybe the benefits of one versus the other?
Yeah, sure. One of the reasons we got into this was the Bosch camera that had fiber right on board, right? So we wanted to talk more about that because first, before I get into differences, the idea is that there's more things starting to get connected. And these things that are being connected are not just being connected by category cable, but directly by fiber. So the camera option is a very good example. And when it comes to fiber optics, there's two main types when it comes to single mode and multi-mode. And literally by the name, you can hear the differences there. Multi-mode, which has primarily been installed in a lot of in-building spaces, connecting different IDF closets to end devices. A lot of short-range stuff has been utilized. Great solution. Literally does have multiple modes of light being transmitted and pulsed at the same time. It starts out at one end, laser optics, and it receives with lasers on the other end. And the idea is that all those pulses of light come out at the same time. With single mode, literally, it is a single mode of light that is going through that piece of glass and doing essentially the same thing, but it's one mode of light, which has advantages to it. With multi-mode, if you go back just real quick to show the core sizes there, you can see on the far left that there's a 62 micron, and then there's the 50 micron. Those are two multi-mode sizes of core size. So when you make up a piece of glass, literally there's the core, which is where the light, it's pure glass that when we put it on, there's a coating, it's called cladding. So the core is pure glass inside, and that allows that light to travel through it. Those multiple modes, for example. So the core size is important, as you'll see in just a little bit, to make sure that things are matching up, not only on the optic side, but the connectors and things like that are very important. So a lot of the stuff, if you've been inside buildings, you'll see a lot of orange looking fiber. If you paid attention to any fiber optics, sometimes that's multi-mode typically. So the orange jacket is very common. As you start getting into the next type of fiber types with 50 micron, this would be things like OM3, OM4, 5. You'll see aqua. It's pretty typical color. There can be different jacket colors, but that's typical. And then single mode, which is even a smaller core, that 9 micron or so. The it's a lot smaller, but it allows you to travel a lot farther because there's less attenuation over longer distances. And you'll typically see that with a yellow jacket if you're inside in those spaces. So the idea is to keep that light in the glass as it travels from one end to the other. And when it's coming to outdoor environments or long reach scenarios, that's where fiber is taking a play. So that's the differences between, and if you see some differences between the two. Multi-mode, you can see like the snapshot in the middle there. You can see the core size is a little thicker, compared to a single mode type of fiber. In the past, single mode has been something utilized a lot of times for just long distance runs and connecting IDF closets, things like that. Multi-mode, as I mentioned, indoors. Some of the advantages to multi-mode is that short. It's been a great thing to utilize indoors. Maybe a little bit easier on alignment on the cores when you actually match things up on the connections and even fusion splicing, things like that. The transceivers of these for multi-mode have come down in price, or they're pretty economical. But single mode these days have actually, the pricing of the transceivers have come down now, and things are starting to pair out a little nicer. So when it comes to the advantage of single mode, it is that ability to go longer distance. And a lot of these camera solutions are outdoors, right? So, and they tend to be long distance. And you mentioned the 300 foot or 100 meters that you typically see in IEEE connections to get that connectivity out there to the edge. This allows you to go a lot longer distance. And if you move on, we'll see, I think, some distance. Yeah. So we put some of these slides together in a hybrid approach here so you can see some of these things on a screen, get an idea. If you look and not focus as much on the other parameters, but down where I have the red rectangle there, if you're looking across the board, OM1 through OM4, you can see distances there for different speeds. So you got 1 gig, which is pretty typical. I know a lot of cameras work on 100 meg, for example, but a lot of these cameras are starting to go 1 gig. It's a very common connection. If you're doing Ethernet connection, very common to be 1 gig. So we're looking at that distance and that capability. As you move across from OM1 to OS2, you can see those distances greatly increase, right? So even with multi-mode, you can be limited to around 1,000 meters. Still a good distance, a very far distance to handle 1 gig. But as you get down to the 10 gig capability, you may not need that today, right? Because the actual amount of speed that you need for certain connections aren't there yet. But there are other applications out there that may require it, and eventually you might need it. You might need that 10 gig. So if you're making an investment in putting fiber in the ground, at least when I do designs, it's typically going to be single mode or OS2, which allows you not only get that distance and really not to worry about it, but it's going to get you out to the edge. Not worry about the bandwidth today, but be ready for the bandwidth tomorrow. It's very flexible as well.
Yep.
So you can do other things with it.
No, absolutely. And as you and I were chatting earlier and getting ready for this, we were talking about, and it was interesting to me, the different types of fiber connectors there are. And so you want to talk a little bit about what types of fiber connectors are typical, and then maybe what applications or when we would run fiber to a camera versus category cable.
Sure. So, like we were just talking about, there's different types of multi-mode fiber, different core sizes, and then there's single mode fiber. When it comes to connectors, there's multiple types. And if you've done the installation of different fiber connectors out there, either from fusion splicing or you've done mechanical connections, there's different connector types that are actually into devices themselves. I think, Moses, you got an ST connector on a media converter right here, for example. So there are different types of connections. The difference is just really the type of, actually the way it's built. There's SC connectors, same Charlie. There's LC connectors. They're the ST version. Those are more common. There's a few other connectors that are out there, but these are the most common ones that you see. And I would say most days I'm seeing mostly LC connections. So they're little, connections. We have some examples at the booth that we can show you. And then there's different types of polish, if you will. So there's angled or there's flat, if you will, UPC versus APC. It's important not only to get the right fiber type on the connector correct, making sure if you are doing multi-mode, make sure you have the right multi-mode type of connector. It's compatible with that core size. if you're doing transceivers, which we'll talk about probably, it's important to understand that you're having the right fiber type and connector that's across the board going to mate nicely across so that they actually have those right connections. So it is important to match the fiber type. Make sure you match the fiber connection type to the device that you are plugging into it. And then the other thing is, if you go back one, you can see that difference there between angled and UPC flat connection. So with a APC connection, they come in on an angle like this. It was built for back reflection to improve that, especially for analog devices that were connected to the different type of fiber. So an example of that might have been RF TV. It's better to have better back reflectance, which improves the signal capability. So that you'll see that on maybe PON designs and other things like that. But typically in the Ethernet world, it's going to be that UPC or that blue connector, that flat connection, and just make sure you got the right type for the application.
Fantastic.
So I hit transceivers, yeah.
Yeah, no, absolutely. And talking about that and talking about, PoE, fiber. So if we're using fiber to a camera, how does that camera get its power?
Well, as far as there's the connectivity piece, first off. So we were making sure that we're matching those connectors up for the transceivers, because they can vary based on what you're trying to do on the switch side as well as the camera side. So the Bosch camera Gen 6 has got maybe, I don't know, who can tell me what is it? What type of connector does it have typically, or can it be varied?
For the fiber,
Yeah.
we do have an SFP connection, and it cannot be varied. It's just a typical one.
It's a SC Sam Charlie?
Correct, yes.
Okay, so that's an example of, looking at the requirements, because if you showed up with a different type of connector that wasn't Sam Charlie, then you would you'd be making a change. But you might be the day you're trying to set this up, and now you got to wait until you get the right connector type there. So it's important to make sure that you're asking those requirements. As far as the powering side, which is the other side of the equation, a lot of cameras can be powered via PoE, and some cameras can be powered via DC input direct. It's important in most cases with a media converter, if you are powering it, and you guys can get into this more detailed, of how to get that device connected with power. So there is an option that we have, which it's called our Actified cable. It's a hybrid cable. It has both fiber and copper conductors in the same jacket. And then the origination piece, or the power supply, sits back in a closet typically, and it's a 56 volt DC output. So the goal is to deliver roughly 48 volts of power by the time you get to the edge or to the camera location. So you size the copper conductors accordingly based on the distance. So in a design, I will always ask what type of camera is it for one. So how much power are we talking does the Gen 6 camera pull max?
It's about 60 watts.
60 watts. So that's a good amount of power for a camera. They vary in power depending on the type of camera you have. So some might be 15, like a fisheye camera, right?
Correct, yeah.
You might have maybe a 360 degree camera. Might be
we have
watts.
the MIG, for example, that can pull around 70 watts. So it depends which type of camera we're talking about.
Okay.
We have cameras with illuminators, so
heaters could be another thing,
correct,
right?
yeah.
So all these things, if you're looking at a spec sheet, that's one of the equations that you got to look at when you're sizing this up, if you are going to remotely power it using this type of solution. As far as the location and the distance is very important as well, because I look at that max distance, and there's definitely a calculator to help you understand, what is the power draw I'm trying to get. I'm trying to deliver a certain amount of voltage, and then that supports this distance. So if you look at those things all together, then you can solve for the answer and what you're trying to do. And when you look at a topology like this, you can get an idea from one end to the other what you're trying to put together. You have the power supply itself. You have your management. You have that cable that goes out with the copper conductors, and then that's how you can power it. So there's other options that you guys can talk about as well.
I guess you're trying to compensate for the voltage drop over the wire length and stuff.
That is correct. Yeah, the thicker the gauge, the more less resistance that you would have over that distance. So you can vary that. So to get you how far you can actually go with this, you can get easily over 2,000 feet if you needed that. In certain cases, if it's lower power draw, 3,000 feet is possible. The more power that you're trying to deliver at the edge, probably the less distance.
So one of the sessions that I'll be participating tomorrow is about site assessments, and so I guess when it comes to fiber, considerations that have to be taken in is what are the distances we're looking at for the application, what are the different power points, where's the endpoint of these devices, because again, there's a variety of options that can be utilized.
That's correct. Yeah, and sometimes there might be multiple devices on a single pole, so you have to look at that. It might be a scenario where you size the entire call the aggregate of those devices at one pole. So maybe you have 3 devices that might be 15 watts each, let's say. That might be 45 watts worth of PoE budget at that location. So you can look at it that way and try to deliver that over a pair or maybe 2 pair of copper. There's different ways to deliver this power using this type of solution. So the other option, I mean, you guys can elaborate, might be the local power. That might make sense, right? So one advantage of fiber optics is that it doesn't have EMT issues, or it doesn't generate electromagnetic interference. It's less susceptible to surges because it's glass. So you don't have that capability to, maybe if there's a nearby surge or lightning strike that might carry back into the IDF closet or the switching area, you want to avoid that, right? So fiber doesn't do that just because of its mechanics. It's glass. It's not a conductor. But if you use this solution, there are actually copper conductors in it, so surge protection on both ends does make sense. When it comes to if you have an existing light pole or something, and you guys can talk about that, you probably have dealt with it. You can drop that power down and locally power that as well. Right. But the fiber might still make sense because of the distance.
Awesome. Well, Steve, thank you. Appreciate a lot of great information there. And
sure.
I guess it segues nicely here where, and I know from being in the field and working with customers, whether it's legacy coax infrastructure, right, and we don't have the capability to run new cable, and dealing with the existing infrastructure in place, we get asked the question a lot as a camera manufacturer, what options are out there, for media converters. So Moses, I guess I'll kick this one over to you and a couple of questions here. So do you, and are there available media converters that for fiber to Ethernet or from fiber to coax? What's available in the market?
Yeah, so thank you. And a great talk on powering. Always not
cool.
light.
Thanks. Appreciate it.
So we deal with electrons and protons and those things on the cable side, right? And you have the ability with copper, as you mentioned in our opening slide, we talked about having copper and then having Ethernet and then wireless. And at ComNet, we have all those means covered for transmission of signals and also powering options. So directly to the question of do we have converters from Ethernet to fiber? Yeah, we do. And they come in all different form factors. This would be one. So one of the key things with these converters is that they're hardened. They can sit out of plant, unconditioned environment. And give anybody a round of applause if they can tell me up to what temperature they think this thing might operate. Yeah, you got a great memory. So he was the last person I spoke with before we came in here. You have up to 160 degrees Fahrenheit and down to 40 degrees Fahrenheit. So an amazing temperature range.
40? Negative.
Negative. Down, yep. So an amazing range of applications, roadside, on the pole, traffic signals, lots of places where we can take an Ethernet cable and we can extend it out using fiber for many miles. Depends on the kind of fiber that you use, and like you were talking about, single mode, you have those choices to make, but we accommodate many of those options, if not all of them. So you can get really amazing distances. And this is the gold standard really in terms of those communication across multiple mediums, multiple infrastructure. Coax, we can also take coax signals and transmit them back over get power over Ethernet on the coax so that we can power. We don't need that cable, that special cable that you talked about a little earlier. We can get power over Ethernet being transmitted back over the copper to whatever extended distance we may have. Like I've mentioned in the beginning, we do have wireless also that can cover up to 4 miles line of sight with one of our options. We have multiple options. So 4 mile line of sight at 500 megabits a second. And these devices are power over Ethernet, PoE devices at 5 watts with pass-through power. So let's say you supply it with a BT source or even an AC source, you have 25 watts of power that you can pass through to the cameras and different things that are being fed into the wireless client side of the application.
Are there specific applications or environments where you're seeing wireless become more prevalent?
Yeah, so wireless is very prevalent in remote locations. And you're finding now, with all of these cannabis fields, a lot of applications where there's solar power out there, and that power is sufficient for these. So you can set up a network. We also have a device that carries the Raspberry brand that can sit out on the edge and take in 8, 24, 32 cameras and record locally also if you wanted to have a closed system out in a remote location. But many remote locations, we're also finding that really when you have emergencies arising, and you need to set up security in a jiffy, you don't have Ethernet capabilities, you don't want to depend on the LTE network, setting up these private networks are really popular and effective. Very effective.
Fantastic. No, it's great information. And again, we see this a lot talking to customers, and there's not really one size fits all. And whether it's a new construction, new opportunity, or an existing infrastructure, trying to utilize that, all these different technologies are part of that total solution, right? So bringing them together, and you mentioned kind of these environmental, where there's not power, not connectivity, and a lot of these rapid deployment trailers, things of that nature that will include cameras, all of these devices that can be easily deployed in those scenarios. So I appreciate that.
Absolutely.
We'll now go to Bogdan. Talked a lot about fiber and connectivity, and so ask my Bosch colleague here, do all cameras or any Bosch cameras accept fiber directly to the camera?
Not necessarily all cameras. That's why I prepared these slides here at first to show how most of our cameras work in terms of fiber connection. It's not necessarily a direct connection. We actually have to have a media converter in between. We will have a media converter at the network side, or maybe we'll have a switch with an SFP hookup or something like that. And then for these type of cameras like the MIC and the Dinian 7100, you will need to have another conversion kit close to the camera. And we typically provide these, and we have hooks to install these type of kits into our cabinets or power supplies and stuff like that from where it takes its power. And then the Ethernet cable, it's very short to the camera itself. But it's also interesting to understand how these systems work before I get into the Autodome 7100, which is a direct fiber connection. And the way we do it, we have the Ethernet coming into the camera itself, and from there it goes into the physical layer of an integrated circuit, which we call the PHY chip, which converts it to MII, which is the independent interface that communicates with the SoC, and the system on chip handles all the traffic in and out to the camera. And because there is just a single PHY, you can only provide Ethernet connection, which is copper Ethernet, and we need this type of conversions. If you switch to the next slide, here you can see, at the MIG side or at the Dinian side, we have this converter kit that you will have to install to actually create fiber. And then at the network side, you will have these ComNet boxes that Moses was talking about. And then we can combine them with all types of SFP modules, cables, as Steve was presenting earlier, and we can get the distance for that. And in terms of power, we typically power our cameras with 24 volt AC, or we can accept 36 VDC. And I had a discussion with Steve probably to provide 48 capability for the future. Now knowing the way they provide power to our cameras, it's probably a good thing to look into our designs. And now if we go to the Autodome 7.
I have a question though. Is it typically a single fiber for your connection there, or is it, it can vary, or is it a duplex connection?
It is a duplex. It can vary. So
it can vary.
Yeah,
Okay,
you can
so
have a duplex or a simplex. You can have multi-mode, single mode. So it's going to depend on the SFP. And like you mentioned, we always try to educate our customers to use a compatible SFP at both ends,
Right.
such that you don't have any type of misconnections or some weird stuff.
Yeah, that's a good point. I think we were talking about this earlier. Is like, so if you do it a simplex connection, which is a single fiber connection, that means you're transceiving data over one single fiber. So the transceivers on both ends are different.
Correct.
So you have like a transmit. There's different wavelengths going one direction, and then wavelengths going the other direction for your two different connections, right? As opposed to a duplex connection, which has a transmit and a receive on each fiber.
Right.
So that is the difference between a duplex connection and a single connection. The thing with the simplex version is that you can buy these transceivers, and they are two different parts. If you have the same one, you have a bucket of these things, and you have, let's say, 10 cameras or something. If you put in the same type, an uplink and an uplink, let's say, they're going to butt heads, and they won't get a link. So just keep it in mind that a lot of times they're color coded. Just a little tip if you do a single connection, just to make sure if you don't want to climb up and get back in the bucket truck or whatever.
Yeah.
So back to the Autodome 7100, which has been released this year. So what we have created for this product, if you see that block called Ethernet or SFP, we created a set of integrated circuits in which we can accept either copper, Ethernet, or an SFP module. Currently, we only support 1 gig. We were thinking that people will go towards a higher bandwidth network in the future. And of course, we have more and more streamings that are happening right now with the cameras. And that's why we went to 1 gig. But if we have enough customer requests to drop to 110 Mbps, we can do that. The only thing is when we drop to 110 Mbps, your SFP module has to be SGMII compliant, which is a media modulation scheme that you'll have to be aware. Obviously, we're going to state all that in our installation manuals and everything. So this is what's amazing about this product. Now, freeing up the RG45, you could have multiple choices for power up. You could have DC voltage in, 36 VDC, or probably 48. We're going to look into that. 24 volt AC, and you could also power with PoE and at the same time have fiber direct connection and get fiber communication from the camera up to 1 gig. As long as these SFP modules are compatible with 10, 100, and 1000 base speed, and we should be compatible with most of the SFP modules. And then the next slide is just showing the simplistic network. So basically, we just eliminated one media conversion at the camera, which means you don't have to worry about that. You just drive your fiber cable directly to the camera. And of course, at the network side, you still have to have some type of media converter.
Yeah.
It's fantastic that we have this in the new 7100. Do you see from a roadmap development standpoint us bringing fiber directly into more Bosch cameras in the future, or is it going to be product specific?
I think we will because we have had these requests, especially from the French market and stuff like that. They do a lot of fiber on highways and everything. And a lot of customers believe that with copper wiring, somebody can tamper with. You cannot tamper with the fiber optics. Once you cut the link, it's cut. You cannot tamper it, or you cannot actually hook up to it. So obviously for security reasons, and if some customers believe that fiber is more secure, which I do as well, I think we're going to have more products designed this way, yes.
Again, I appreciate the three of you gentlemen. It's really interesting conversation and learning more about the different options that are there because, again, like I said, and as all of you know, there's really not that cookie cutter. It's whether it's a new opportunity or we're working on existing legacy infrastructure, what fits for one customer or one application may be different than what fits for the next. So having these options is tremendous. I will open it up for questions in the audience.
For ComNet, Bosch, with their new NDMs and Autodomes, made the move to BT on the power configuration. So we had a difficult time matching up our ComNet product line with those, and had to search for some options. What is your plan for getting BT throughout the product line?
So great question. So we are currently, we have a couple of our products that already, they're at BT Type 4. So just to be clear, there are two BTs, right? There are BT Type 3, BT Type 4. Not sure if the Bosch is the Type 4 or the Type 3. Type 4.
Plus 8.
Yep. So we are currently, we have two products that are BT Type 4. A power injector and a media converter that is already at Type 4. And those are available. You can speak to your ComNet person, or, let's have a conversation after. We can get into the details. And we are currently actively working on additional switches and media converters made in the USA line, with BT power. So they're actively being produced right now. Or actively being developed. Let me classify it really carefully.
Can you guys speak to the reason why that change was made to BT, and why
You mean the BT?
we have 3 and 4 as well? Because
Yes,
we're
so-
really struggling. I'm really struggling out there with matching up power to the new cameras.
So there is AT, AF, and BT. No, AF it's 15 watts or 13 watts. AT is 25, 30 watts, and then BT is higher power, up to 90 watts at the injector or 71 watts at the camera. The PTZ cameras that we develop nowadays, they require higher propagation for illumination, for example. No, so we want to reach larger distances at night. We also go lower in temperature to minus 40, and we have cold start requirements to actually start up at minus 40 degrees, which is a very cold environment. So that means we have to have very powerful heaters. Because of that, we are surpassing the ATAF power limits, and we have to go to BT. Before BT, there was an out-of-standard type of power over Ethernet called POH that was developed by Microsemi, now Microchip, and that was 95 watts. But the idea is to stay in standard and be compliant to as many injectors as possible, because there is a hardware negotiation scheme between the injector and the PD chip that we install in our cameras, which is a power device chip that sends us some pulses to actually negotiate the level of the power that the camera desires. So that's why we would like to stay in the standard from now on with our cameras, and be able to negotiate with as many injectors as possible. And my opinion is that most of these injectors that are in the field right now, they will converge towards BT, away from the POH that Microchip actually has right now. And actually, even Microchip, they developed their own BT standard PD chip and PSE. PSE is in the injector side. So, nevertheless, we are also required to be backward compatible with ATAF. The thing is, when you hook up a camera that is powerful and needs more power to an AT, for example, injector, the only thing that you will be able to do is probably see a video and an OSD display saying you don't have enough power. We don't try to just cut you out and then you don't know exactly what's happening with the camera. We will display something on the video. But we will cut motor control, we will cut heater or illumination control and let you know that you have the wrong injector. Does that answer your question?
Yeah, it does. I mean, we've experienced all that. I'll go through and kill the IR on the NDM 7503s to get them to run. We are seeing some other problems with those cameras that maybe isn't related to the power. We can discuss that.
Okay, yeah.
What's the distance from the media converter to the actual camera, typical?
Within the copper channel,
Within
we're not.
IEEE standard is what you're saying?
So 100 meters.
Yeah, 100 meters.
Yeah, 90 meters
Yeah.
plus 10 meters of jumper.
Yeah. I asked different cable types have different resistance levels, and if you're within the standard, then it should be all right.
I started in the datacom business. I'm an RCDD, so we're probably cool on the cabling side of it.
Got it. Yeah, cool.
I want to thank the three of you gentlemen for joining and providing your level of expertise. So thank you again, everybody.
Thank you, folks.
Bosch, invented for life.